All right, let's just jump right in. If you're getting your feet wet with Python, you have absolutely met its infamous error messages. You know, it can feel like you're just running headfirst into a brick wall. But what if they're not walls? What if they're actually helpful signposts? Today, we're going to demystify some of the most common Python errors out there and show you exactly how to read those signs and get your code back on track.
You know that feeling, don't you? You've been working hard, you've written what you think is some pretty solid code, you hit run, and boom, a wall of red text just pops up. It's so frustrating, and it can make you feel completely stuck. But here's the thing. Every single programmer, and I mean everyone, from total beginners to people who have been doing this for decades, they see these messages every single day.
So, what if you had a map for navigating those errors? Well, that's exactly what we've got here. This awesome little guide breaks down the most common errors into really simple, understandable categories with super clear fixes. Seriously, think of this as your personal cheat sheet for debugging your code and, honestly, for building up your confidence.
Okay, so here's the game plan. We're going to start with the simple stuff, grammar and spacing mistakes, then we'll get into cases of mistaken identity and type. After that, we'll look at what happens when you try the right action but in the wrong place, and to wrap it all up, we'll give you an essential debugging toolkit and a whole new way to think about errors. Let's do this.
First up, let's talk about the errors that are pretty much the coding version of typos or, bad punctuation in an email. I'm talking about syntax error and indentation error. These are all about just following the basic rules of the Python language.
So a syntax error is, well, it's exactly what it sounds like. You've broken one of the grammar rules of Python. It's kind of like forgetting a comma in a sentence or a question mark at the end of a question. The computer's trying its best to read your instructions, but the mistake just makes it impossible for it to understand what you're trying to say.
And you know what? The fix is usually surprisingly simple. Just look at this incorrect line here. Python sees if true, and it expects a colon right after it to signal, okay, here's the stuff you should do if this is true. The correct version, it just adds that colon. That one tiny little piece of punctuation makes all the difference.
Next up is the indentation error, and this one is a classic in the Python world. See, in a lot of other languages, spacing is just there to make things look nice, but not in Python. Oh no, in Python, the spacing, the tabs at the beginning of your lines, that's a critical part of the grammar. It literally defines the structure of your whole program.
And this shows that point perfectly. In the incorrect example, the print command is on the same level as the if statement, so Python has no clue that it's supposed to be inside that if block. By just adding that little bit of indentation, you're telling Python, hey, this line of code, it belongs to the statement right above it. It's all about that structure.
Okay, so we've got the grammar down. Now let's move on to our next category, which is all about mistaken identity. This group of errors is all about what your data is called and, well, what kind of data it actually is.
A name error is kind of like calling out to a friend in a crowded room, but you use the wrong name. Nobody answers because nobody recognizes that name. It's the same in Python. If you try to use a variable that you haven't defined yet, the program just stops and basically says, I have no idea what you're talking about.
And the fix is incredibly simple. The first line tries to print X, but the program is like, what's X? You just have to introduce it first. In the correct version, we first say X equals 5. And now that Python knows who X is, it can totally print it out. You've got to define a name before you can use it. Simple as that.
Now, a type error is that classic apples and oranges problem. You're trying to do something to a piece of data that just doesn't make any sense for its type. The most common example? Trying to add a number to a word. I mean, you can add 2 plus 2, but you can't really add 2 plus hello, can you?
This slide shows a really great, subtle example. We're trying to add the number 1 to the string 1. Now, to us, it looks like a number, but those quotation marks tell Python that it's just text. So the fix is to tell Python what we mean. By using int1, we're basically saying, hey, treat this piece of text like an actual integer. And bam, the addition works just fine.
All right, let's move on to our final category of errors. These ones are all about trying to do the right thing, but on the wrong kind of object or in the wrong spot. Let's take a look at attribute error and index error.
Think of an attribute error like this. You're trying to use a feature that something just doesn't have. It's like trying to use a car's turn signal on a bicycle. The action makes sense, but not for this specific object. Different types of data in Python have their own unique set of abilities or methods, and you got to use the right one for the right type.
And here we go, a perfect example of that. Someone here is trying to use .append. Now that's a tool that's specifically for adding an item to the end of a list, but they're trying to use it on a string. Strings just don't have an append method. Lists do. This is a great reminder of why it's so important to know what kind of data you're actually working with.
An index error is actually pretty straightforward. Imagine a list is like a bookshelf with a bunch of items in numbered slots. If you've got 3 books on the shelf, but you ask for the book that's in the 10th slot, well, that's an index error. You're asking for a position that's out of range. It just isn't there.
So yeah, if our list only has a few items in it, trying to grab the item at index 10 is always going to fail. To fix this, you just have to access an index that actually exists. And this brings up a super important thing to remember about Python. It always starts counting from 0. So list 0 will get you the very first item. Always remember that 0 indexing. It'll save you a lot of headaches.
Okay, so we've covered how to fix a bunch of specific errors, but let's zoom out a little bit. How do you just become a better problem solver in general? Well, that's where your personal debugging toolkit comes in. These are the habits that will help you solve any problem you run into.
Here's your 4-step plan. Number 1, use print statements. Just sprinkle them in your code to check what your variables are doing at different points. 2, actually read the traceback. That's the big error message. It literally tells you exactly where the problem is. 3, for trickier bugs, learn to use a debugger tool. It lets you step through your code line by line. And 4, when in doubt, check the official Python documentation. It's your best friend.
And all of this, it brings us to maybe the most important point of this whole thing. It's not just about learning how to fix errors. It's about completely changing how you think about them. So here it is, the big takeaway. Errors are not your enemy. They are not a sign that you're a bad programmer. In fact, they are the exact opposite. They are proof, definitive proof, that you are building things, you are experimenting, and you are learning. Every single error is a helpful little clue, a message from the computer that's guiding you one step closer to a solution.
So instead of being afraid of that red text, start seeing it as your partner on this coding journey. See it as a signpost, pointing you in the right direction. The real question isn't how to avoid errors. The real question is, what amazing things are you going to build now that you're not afraid of them?